Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Jupiter moon hopping series that I'm doing. In the first set of videos, we went from Callisto to Ganymede, so if you haven't seen that set of videos in the first hop, I would highly recommend that you watch that first, because I went through and explained everything that I was doing in a lot of detail and took notes while I was doing it. So I think there's a really good learning opportunity there if you're wanting to learn how to use IMFD. So I anticipate that in this next hop, where we're going from Ganymede to Europa, that it will probably move a little bit faster because there just isn't as much to cover. I've already taken the notes basically, so there won't be quite as much to do there. There will be a little bit of additional note-taking in this video to kind of fill in some of the gaps that I had in the last set of in the last hop. So let's go ahead and get started, and I'm going to actually use my previous notes as a checklist or a guideline to go through. A couple of reasons. Mainly, I just want to test the notes. So if I can follow my own notes and do everything that I said to do previously and have a good outcome, then I know the notes are good. I used to do this all the time with transects. This is actually how I taught myself how to use transects. I would get into Orbiter and just, step one, step two, I would write down exactly what I was doing. Then I would go back to those notes and just go through it step by step, and until I ran into a problem, and then I would fix the notes and so on. And anytime I ran into something I couldn't answer, I would back then I would contact FlyTandem through Orbiter Forum, because I didn't know about Dimitri back then, so I was always talking to FlyTandem, and he was always great about answering my questions and helping me learn transects. Without him, I don't know if I ever would have learned transects, and without Dimitri, there's no way I would have learned IMFD, at least not as quickly as I have. So let's go ahead and switch camera views here. And let's just refer to the notes here quickly so we can see what we need to do first. And this is just some stuff here at the top, so we don't need to really worry about that. But part one, we're just going to do the same thing we did before, and that is to open IMFD and bring up the target intercept program. And we get to that by menu, course, target intercept. So let's do that. Bring up IMFD, menu, course, target intercept, and there we are. And then in the next step, we want to target the destination. Target the destination by pressing target and typing the name. So target Europa. Okay, what do we do next? Now in the target intercept program, press NXT until you get to time of flight unlocked. Then we want to toggle that to locked. Okay, so let's do that. And now we want to go to the MJD of arrival, which is under the TIN, and we want to use plus or minus to find a more efficient time of arrival. The best time of arrival is when the DV is at its lowest. So let's do that. So we're coming to the MJD here, and in fact, a quick point, when the time of flight's locked, it actually doesn't matter which MJD you're using, but we'll just use this one. So we want to find the most efficient time of arrival. That's going to be when the total delta velocity is at its lowest. And again, the OV is what it costs us to leave this body, and the IV is what it costs us when we get there. It's interesting to note that those are different, because if you're going to a body like Earth or Mars that has an atmosphere, then you can kind of ignore the IV and just focus on getting the lowest OV, because you're going to use the atmosphere to brake when you get there. So let's do these adjustments and watch our OV, our total rather, and find the lowest number. 5, 4.4, 3.9, 3.5, 3.2. Now it's going back up, so let's back up to the 3.2. And let me see if it's in my notes where I say to, yeah, once you have the lowest DV, toggle. What I might want to add here, well, what I want to add in there is, once you find the lowest DV using the MJD, you can also refine it using the TIN. So let's do an adjustment here, and you can see it's coming down a bit more. So I'm going to actually add that to the notes. So let's go to there. Now that's the lowest. So let's just add in a step here real quick. So step 5 is once you have the lowest DV width by just adjusting MJD, then go to TIN, or let me just say TIN, then go to TIN and do a further adjustment and then do a further adjustment. The TIN/TEA adjustments are finer. Actually, let's put that in italics. Are finer, so you get more granularity. I think everybody knows what I mean by all that. Okay, so we've done that. Now let's go, once we have the lowest DV, toggle time of flight of locked back to off, and then we want to go to the MJD of the ejection, and we want to adjust the ejection to see if we can bring this down even more. And you can see it went down some more. 120, 115. Now it's going back up. And I believe I have that in the notes here. Go to the MJD and use plus minus to find a more efficient time of departure. Okay. And I guess I don't have it in this part where you go back and forth. Maybe that's a little bit later. But again, you know, when you get to this point, you can also, now that we brought it down a little bit more on that side, we can try to bring it down more now that these are unlocked by doing that. And that's, you can see it went down a little bit. We went from 115 to 096. And now it's going up. And we can do finer control here using TIN and TEJ just to find that, make sure we got that lowest point. Oops, that's too much of an adjustment. Let's go to 10. See, it's still coming down, and that's you know, that's quite a bit. Okay, we'll go with that. Now let's go to the TEJ, and that's going to have a little bit more of an impact, not much. But sometimes when you go back and forth between these variables like this, you end up saving, you know, 100 or 200 dV. But in this case, I can tell we're pretty much at the lowest point. But let's check again, because anytime it's going down, you may always continue to get a little bit more out of the other side, like we're doing here. That's actually giving me a surprising amount, so we'll go with that. Now again, since we did get some benefit out of that side, we'll go to this side again. And it's coming down a little bit more. And that's about the low point there at 305. I don't know that you necessarily want to overshoot on these like you do when you're using the delta velocity program, so we're not going to do that. And it's still coming down. I mean, if you consider how much total we've saved here just by going back and forth from where we started, I think it's, you know, I'd have to look at the video playback to know the number, but I think we started at like 3096 or something, so we're almost 100 meters a second cheaper already. And that's probably the very lowest right there, because you can see we only got 1 meter per second out of that. So if I come over to the other side, you know, I don't really think it's ever going to get any lower. And that's how you know you're done. When you can go back and forth between both sides and not get any improvement at all, you're done. Okay, so what do our notes say to do next? Okay, if your departure MJD is greater than 1 day, in other words, if it's more than 86.4 K, then use the scenario editor to move the date forward, or use time warp until you are just 24 hours from the departure time. TEJ will be about 86.4. So what we're talking about there is our TEJ. In this case, it's only, you know, it's less than a day out, so we're not going to do any kind of time warp or scenario editing on the date. But if the TEJ were like 500,000, or if it were like, you know, 1 million or something, then you would want to bring up the scenario editor and just get within 1 day of launch, because for one, you don't want to sit there for that long and wait, and for two, once you warp time forward by a whole bunch, then things can kind of change a little bit. The plan that you have set up won't quite be valid, so you definitely want to warp time forward and then kind of refine the plan. So we don't have to do that, but now let's see what our next step says. After you have adjusted the MJD and found the lowest DV, change to the TEJ variable and make adjustments to ensure the DV is actually at its lowest value. Note that when you adjust the TEJ, you will probably need at least 10x setting, and in some cases you will want to start with a 100x setting. So basically that's what we just did, when we were sitting there going back and forth between the TEJ and the TIN. And that's actually what it says here. Now alternate between the TIN on the right and the TEJ on the left to dial in the absolute lowest delta V. So we've done that. Once you have the lowest DV, toggle time of flight unlocked back to time of flight locked. So let's do that. Now we're locked. And go to the MJD of departure or arrival and advance time forward and see if you can get a significantly lower DV at some point in the future. Kind of a note here. Since the time of flight is locked, it doesn't matter if you adjust the TIN MJD or the TEJ MJD. So with this locked, everything that you change here has the exact same effect on this side. So in fact, it doesn't matter which one you edit. But you might remember in the last video, again, hopefully you saw that hop where we were talking about, once you have the lowest delta V here, this is the very next opportunity. But we may find actually that we can accomplish the same flight if we go forward in time to another position. Don't take it for granted that the very next solution that you find is the absolute best. In a lot of cases, it won't be. So one thing we did in the other video too, and we'll do it here again, if we bring up transx, and again, the only reason we're doing this is because we just want to see where the line of nodes is at. There's no way to do that using this MFD. So we're going to go plus, we're going to go escape rather than we're going to go forward, and we're going to select Europa, press VW to bring up the eject plan, then put in some amount of prograde, it doesn't matter how much, so one click is fine, and now we've got the line of nodes. And again, we can eyeball it, so if we count 3 buttons down, and it starts at about right there, and goes across to about right there. But I like to use this line drawing tool, and again, I have links to this in the description down below. This part of it is free, the distance measuring part is free, so you can download it and use it for free. And we're going to lay that red line right over top of the line of nodes, about like that, and maybe do a little bit more adjustments. In a perfect world, you wouldn't be able to see the white line if we get the red line exactly where it needs to be, but that's good enough. Now we're going to drag this line until it's straight over top the middle of Jupiter. Right there. Maybe up one more pixel right there. And you can see, if you kind of eyeball it, that it's where it needs to be, but the point is it needs to be over top the center of Jupiter. And so now we have sort of an artificial line of nodes in interplanetary MFD. What this tells us is that we are leaving Ganymede here, and we are arriving at Europa over here. So we're not arriving at a node, and we're not leaving at a node. Actually, I guess it's mainly, I think it's the arrival that matters, not so much the departure, but we're not arriving at a node. So it very well may be the case that we get a significantly lower total delta V if we bring time around until we happen to be arriving at a node, and let's find out if that's the case. So we've got the time of flight locked, and we'll want to make a note of what our current delta V is so that we know if we're beating it or not, because it's very easy to take time forward and see another number, and then you're like, okay, I actually don't remember if this is better or not. So the total here is 3002, and let me just put it in parentheses. I want to put that breakdown 1.399/1.602 is the breakdown. Okay, so 3002, and with the time of flight locked, we can always get right back to this exact position, so we don't have to worry about saving the scenario or anything like that. So up here to the MJD, and we're going to go forward. That's on 10, I don't want that, so actually let me go back to 10 and then rewind back to where I was, and then now to 1, and now go forward a little bit at a time. And I'm just watching the total DV. Again, we're looking to beat 3000. You can clearly kind of tell when you're getting close, because then this, your orbital path turns into, more normal looking. And see, here we're at 313, so we're not beating it, but again, we're almost in the same position. So I'm thinking we're probably not going to beat it. At least not by any significant amount. So going around again. See, here we would be arriving at a node or close to it, but the timing just isn't working out quite right. So there's 3002 again. What if we go forward? Now we're not quite beating it. It's possible, though, at this point, that if we do an unlock now, let's find out. If we play around with it, because now we're tied, right? We're tied with the lowest point. So it's possible from this position, and we've got a slightly better looking Hammond transfer here. So I'm guessing that we can beat that 3002 from here. So now we've unlocked. Okay, let's go. First of all, let's check the arrival, or the departure. Okay, that's not helping. Let's check, let's see with the TIN. It's coming down a bit. So that number, and now let's check TEJ. And back this way. So it's not a big savings. It's only 8 meters per second, but it does, show that there is some potential savings, depending on how you do this. So let's lock again, and let's see if we can find a better solution yet. And, something Dimitri always says, when you do this, you have to pick a point where you decide that's good enough. I'm not going to mess with, 5 or 6 meters per second. It's not worth my time. But the fact of the matter is, you can't know how much better you can get unless you check. So, but at some point, you just have to decide, okay, that's enough. So let's go back to the 1x. Let's go forward. And now we're looking to beat, actually, let me go back, so I already forgot exactly. Now we're looking to beat 2993. Let's go forward. And we can, when we get like that, we know that it's just going to get worse, so we'll just swing it around very quickly. And then we're not going to get a better delta V until it starts to look more like that. So there, again, we're not really beating it, but it kind of looks to me like we're almost getting a little bit of an improvement sort of every time we go around one time. So let's kind of see what we have here. No. Wonder why that's so high. That's interesting. All right, let's go all the way around. We're just going to do this like one more time, and then we'll pick whatever we've got. So now we're down to 2989. See, that's a bit better. So we'll take that, but let's go forward. That doesn't help. Backwards. Now we're going to do the same thing. We're going to unlock. And at 1x, let's see what happens if we adjust the arrival. That's worse. That's worse. Let's adjust the departure. That's worse, and that's worse. So last thing, we'll go to the TIN, do an adjustment here, and just play around, see if we can beat 2989. And that's coming down. So now we're saving, compared to the first thing that we came up with, we're now saving 23 meters a second. Not huge, but, again, if you're really looking to push things to their limit, then this is kind of what you need to do. Now, arguably, if I kind of wanted to keep the time close to the current date, because I'm recording this video like March 10th. Yeah, March 10th. So when I took off originally from Callisto, I was really close to the actual date. Now I'm saying that I'd be pushing the date out by like, 2 million. That's like almost a month. So if I want to say that I don't want to save that extra 20 or so meters per second, then I can go back to the first one that I had, which had the delta V of 3002, and it would be much closer to today's actual date. In fact, it is today. But let's go for the lowest DV. Let's be DV freaks here. Can blame Dimitri for that one. Turned me into a total DV freak. Okay. I'm going to say that's good enough. Obviously, if you want, you can continue to play with this a little bit more, and you might even be able to do better if you get this closer to a Hammond transfer. You can see we are leaving here, we're arriving there, and maybe if we go forward 1 or 2 more times, then we'll have a more perfect Hammond, and we'll save another 20 or 30. It's possible. But we're not going to do any more because just, time becomes an issue. So let's kind of do what we have in our notes, which is when the TEJ is greater than a day, we want to move time forward until the date is just 1 day out. And then we already have that in the notes. And again, it's going to be 20 days or so. Okay, there we are. That's about 1 day, but let's go forward a few more hours because that's a little more than a day. And that's about a day. That's actually really close to 1 day. So we're done moving the clock forward. And here's the thing. Here's the thing about this whole process is notice that even though we found the lowest delta V and we got it down, we were saving like 20 meters a second. When we warp time forward or when we move the date forward, everything here becomes more up to date and more accurate. And you can see now that all of our savings went out the window. It's for naught. So what I'm going to do actually is I'm just going to reset the date back to today. That way we can keep the date around the real time. I'm not going to bother doing that, but I mean, you get my point. Sometimes when you're setting all this stuff up so far in advance, it's a waste because you end up losing all your gain by the time you bump the clock forward. But as long as we're here, let's just play around a little bit with the TIN and everything and see maybe if we can get it back down to that low point. Yeah, we're getting a little bit of benefit there. Let's do 100, see if that's too much. So at least we're getting some of our savings back. It's down to there. Now over to the TEJ. Taking away a little bit of that time. So I guess it's still a little bit worth it. We're still getting 22 meters per second savings by doing this, but it's not as much as it was before we move time forward. And again, that's just one of the things I've noticed that, once you move time forward a bunch, you lose some of your benefit. So a little bit of change there. Still coming down. No, 79 is the lowest, so we'll take that. Okay, now, and again, we're done with this line drawing tool. We can close that out. Control click, that's gone, and we don't need transx for anything, and we're less than 1 day out. So let's go ahead now and bring up IMFD on this side. Actually, let's look at our notes. So go to the MJD, and we've already done all that. So we've done everything that we wanted to do there in part 1. So the next part, for some reason there's an extra page in there. The next part is to bring up IMFD on the other side and share it with the other instance of IMFD. So bring up IMFD over here, menu, share, side 1. Now load the surface launch program and make sure that it is using the course program op mode. So bring up orbit eject. Is that what I said? No, surface launch. Bring up surface launch and make sure that the op mode is course program, which it is. Now set the target orbital altitude located right under the course program on the left side of the MFD, not the right side. It's over here. So set, and again, I'm going to go for 30K. Okay, now the right time to, let me say launch, is dictated by 2 factors. The first factor is how close you can get to a 90-degree heading in some cases, such as being on the moon or being on a moon like Ganymede. The launch heading simply does not matter. So actually, let me check that. So here we are on Ganymede. You can see our velocity. What I meant to say there was not Ganymede, because I was on Callisto when I wrote this. So you can see our rotational velocity on Ganymede is 25 meters per second. And as I explained in the other hop, when you take off and go to the 90-degree heading, this velocity is working in your favor. So it would cost you 25 meters per second less to get to your orbital velocity if you're going, like with the movement. So the body's moving this way, and if you're moving with that, then it's kind of throwing you forward. But the opposite is true if you go backwards. So if we go to a 180 heading, then the object is moving this way, we're going that way, and it's kind of working against us, and we're going to have to actually increase our velocity by an additional 25 meters per second. So ideally, we want a heading of 90 degrees. Now, since these moons are tidally locked, getting a 90-degree heading often can't happen. So we can see here that in surface launch MFD, our 90-degree heading is 247,000 seconds from now. That is, like 4 days. We're not going to wait that long. We're just going to take whatever heading we can get when we reach the TEJ. And again, it won't make a big difference here because the orbital velocity of Ganymede is pretty low. It's not as low as it was on Callisto, so it will take us a little bit more velocity if we do in fact have to take off at a bad heading, but it won't be much. So that's going to be the next step, is to work time forward until the TEJ is about at the time to go. But let's check our notes on that just to make sure. So again, like on Earth, very important to have the TEJ, in a 90 degree, but we're not on Earth. So if launch heading is not a concern, which in this case it's not, then simply launch at the heading given by the surface launch program when your TEJ is about 1 hour out. So that's what we're going to do. Warp time forward till TEJ is about 1 hour, and 1 hour is 3,600 seconds. I'm actually going to go 4,000, or I'm actually going to go. I seem to recall Dimitri telling me 5,000. So, and I know, when I did this on Callisto, it seems like I took off a little bit too early. So let's go with 5,000. That number sounds, and we'll just see what it's like. But I think that's going to be a little bit better. Okay, so we're coming up to 5,000 seconds, and notice that our heading has improved drastically. So we're not going to have a perfect 90-degree heading, but it's not going to be too bad. Our loss due to rotational velocity won't be too much at all. All right, but let me make a small note here. Launch when your TEJ is about 5,000 seconds. I think that's better. Okay, so we're coming up to 30 minutes on this part of the video, and this will be a good stopping point. When we come back, we will be right here ready to go. We'll have a heading of about 52 degrees or thereabout, and we'll get into orbit and continue on with the flight. So if you like this part of the video, please do hit the like button down below. If you didn't like it, I don't care. No, I'm kidding. But do leave comments. I like comments. I like questions. If you have any questions about anything, if something's confusing, or if you looked at something and said, hey man, you're an idiot, and you could do it way better if you did it like this, let me know. Of course, Dimitri might be offended because he's the one that taught me all this. And if you know more than him, then that's impossible. So I don't even have to speculate about that. I will have some links in the description down below. You can get all these bases that I made and put on the different moons of Jupiter. There's a link on Orbit Hangar where you can download those. And I'll put a link to these notes that I'm making so that you can read over my notes. And as you try to do this yourself, you can kind of go down and just check off item by item. And I'll put a link to the line drawing tool that I'm using. Again, it's free to download and use that tool if you're just using that measurement tool. It has a few free tools. Some of the ones I use aren't free. I actually bought the program. So yeah, that's going to be, I think that's everything I want to cover there. See you in the next video. Okay, welcome to another Orbiter 2010 video. And this video is going to be a continuation in the Jupiter moon hopping series that I'm doing. In the first set of videos, we went from Callisto to Ganymede. So if you haven't seen that set of videos in the first hop, I would highly recommend that you watch that first, because I went through and explained everything that I was doing in a lot of detail and took notes while I was doing it. So I think there's a really good learning opportunity there if you're wanting to learn how to use IMFD. So I anticipate that in this next hop, where we're going from Ganymede to Europa, that it will probably move a little bit faster because there just isn't as much to cover. I've already taken the notes basically, so there won't be quite as much to do there. There will be a little bit of additional note taking in this video to kind of fill in some of the gaps that I had in the last set of in the last hop. So let's go ahead and get started, and I'm going to actually use my previous notes as a checklist or a guideline to go through. A couple of reasons. Mainly I just want to test the notes. So if I can follow my own notes and do everything that I said to do previously and have a good outcome, then I know the notes are good. I used to do this all the time with TransX. This is actually how I taught myself how to use TransX. I would get into Orbiter and just, step 1, step 2, I would write down exactly what I was doing. Then I would go back to those notes and just go through it step by step, and until I ran into a problem, and then I would fix the notes and so on. And anytime I ran into something I couldn't answer, I would back then I would contact FlyTandem through Orbiter Forum, because I didn't know about Dimitri back then, so I was always talking to FlyTandem, and he was always great about answering my questions and helping me learn TransX. Without him, I don't know if I ever would have learned TransX, and without Dimitri, there's no way I would have learned IMFD, at least not as quickly as I have. So let's go ahead and switch camera views here. And let's just refer to the notes here quickly so we can see what we need to do first. And this is just some stuff here at the top, so we don't need to really worry about that. It's going to be when the total delta velocity is at its lowest. And again, the OV is what it costs us to leave this body, and the IV is what it costs us when we get there. It's interesting to note that those are different, because if you're going to a body like Earth or Mars that has an atmosphere, then you can kind of ignore the IV and just focus on getting the lowest OV, because you're going to use the atmosphere to brake when you get there. So let's do these adjustments and watch our OV, watch our total rather, and find the lowest number. 5, 4.4, 3.9, 3.5, 3.2. Now it's going back up, so let's back up to the 3.2. And let me see if it's in my notes where I say to, yeah, once you have the lowest DV, toggle, what I might want to add here, well, what I want to add in there is, once you find the lowest DV using the MJD, you can also refine it using the, but part 1, we're just going to do the same thing we did before, and that is to open IMFD and bring up the target intercept program, and we get to that by menu, course, target intercept. So let's do that. Bring up IMFD, menu, course, target intercept, and there we are. And then the next step, we want to target the destination. Target the destination by pressing target and typing the name. So target Europa. Okay, what do we do next? Now in the target intercept program, press NXT until you get to time of flight unlocked. Then we want to toggle that to locked. Okay, so let's do that. And now we want to go to the MJD of arrival, which is under the TIN, and we want to use plus or minus to find a more efficient time of arrival. The best time of arrival is when the DV is at its lowest. So let's do that. So we're coming to the MJD here, and in fact, a quick point, when the time of flight's locked, it actually doesn't matter which MJD you're using, but we'll just use this one. So we want to find the most efficient time of arrival using the TIN. So let's do an adjustment here, and you can see it's coming down a bit more, so I'm going to actually add that to the notes. So let's go to there. Now that's the lowest. So let's just add in a step here real quick. So step 5 is, once you have the lowest DV width by just adjusting MJD, then go to TIN, or let me just say TIN, then go to TIN and do a further adjustment. to, and then do a further adjustment. The TIN/TEA adjustments are finer. Actually, let's put that in italics, are finer. So you get more granularity. I think everybody